Hello everyone. The square root of any number is equal to a number which when multiplied with the same number gives the original number. We get perfect square roots for a perfect square number. So today let us discuss something more related to this in our lesson Square and Square Roots. Here is a chart showing perfect squares from 1 to 30. Square number. The number you get when you multiply by itself is a square number. Example, 4 multiplied by 4 is equal to 16. So 16 is a square number. Here are some of the examples given below. Look at the example. We have 3 square is equal to 9 and 5 square is equal to 25. These are the examples of perfect squares. Perfect squares. If a number which ends with 2, 3, 7 and 8 at units place, so it must not be a square number. Example 132, 72 and 28. If a number ends with 1, 4, 5, 6 and 9 at units place, so it may be a square number. Example 16. 4 multiplied by 4 is 16. Example 15. As it ends with 5, it is not a perfect square. Property of a unit digit of a square number. 1 multiplied by 1 is equal to 1 and 9 multiplied by 9 is equal to 81. If a number has 1 or 9 in the units place, then its square ends with 1. Another example, 2 multiplied by 2 is equal to 4 and 8 multiplied by 8 is equal to 64. If a number has 2 or 8 in the units place, then its square ends with 4. Another one, 3 multiplied by 3 is equal to 9 and 7 multiplied by 7 is equal to 49. If a number has 3 or 7 in the units place, then its square ends with 9. 4 multiplied by 4 is equal to 16 and 6 multiplied by 6 is equal to 36. If a number has 4 or 6 in the units place, then its square ends with 6. Even and odd squares. If a number is odd, so its square is also odd. If a number is even, so its square is also even. Example, 16 is equal to 4 square, which is a even. 25 is equal to 5 square, which is a odd. 121 is equal to 11 square, which is odd. 144 is equal to 12 square, which is even. And 49 is equal to 7 square, which is odd. Adding odd numbers. If the sum of numbers are in consecutive from 1 and odd, so the square root of this number is the number of observation. Example, 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 is equal to 7 square. The next example, 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 is equal to 9 square. Next one, 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21 plus 23 is equal to 12 square. The next one is odd number of zeros. If a number ends with odd number of zeros, then it is not a perfect square. Example, 35,000 are not perfect square. Also the digit 4 lakh is not a perfect square. 160,000 is a perfect square. Numbers between square numbers. We can find some numbers between two consecutive square numbers. by finding the square numbers of any two numbers. Between 1 square and 2 square, there are two non-square numbers. Those are 2 and 3. Between 2 square and 3 square, there are four non-square numbers. Those are 5, 6, 7, 8 and 9. Non-square numbers. The non-square numbers which is 1 less than the difference of two consecutive squares, that is n minus 1 minus n. Example 9 and 16, which is equal to 16 minus 1 in the brackets minus 9 is equal to 6. Second example 16 and 25 is equal to, in the bracket 25 minus 1 close the bracket minus 16 is equal to 8. There are three more examples given in the following manner. Next subtopic is Pythagoras Theorem. The square of a number is equal to the square of two other numbers. This property is called Pythagoras property, and the three numbers used in this property are called Pythagoras theorem. Here is an example. 5 square is equal to 3 square plus 4 square equal to 25 is equal to 9 plus 16. So 25 is equal to 25, proving it is a right angle triangle. Pythagorean triplets. The formula to find more such triplets is 2m square plus, in the bracket, m square minus 1 close the bracket is equal to m square plus 1. Example 6 square plus 8 square is equal to 10 square. So 36 plus 64 is equal to 100. 100 is equal to 100. So 6, 8, 10 are Pythagorean triplets. Next one. 3 square plus 4 square is equal to 5 square. So 9 plus 16 is equal to 25. 25 is equal to 25. So 3, 4, 5 are Pythagorean triplets. Finding Pythagorean triplets. First one, Pythagorean triplet whose smallest number is 12. So 2m is equal to 12 and m is equal to 6. 6 square minus 1, 36 minus 1 is equal to 35. 6 square plus 1, 36 plus 1 is equal to 37. So substituting the values, 12 square plus 35 square is equal to 37 square. 144 plus 1225 is equal to 1369. So 1369 is equal to 1369. So 12, 35 and 37 are Pythagorean triplets. Next example. Pythagorean triplet whose number is 5. So we have m square minus 1 is equal to 5, m square is equal to 6. M is equal to 6 upon 2 is equal to 3. 2 multiplied by 3 is equal to 6. 3 square plus 1, then 9 plus 1 is equal to 10. Substituting all the values, we have to check 5 square plus 6 square is equal to 10 square. So 25 plus 36 is equal to 100. So left hand side is equal to right hand side, that is 100 is equal to 100. So 5, 6, 10 are Pythagorean triplets. Next one is repeated subtraction. Finding square roots. Repeated subtraction. The subtraction of odd numbers consequently to the number, still we get 0. So the number of observation we subtract to the number is the square root of that number. Repeated subtraction. Find the square root of 64. 64 minus 1 is equal to 63. 63 minus 3 is equal to 60. 60 minus 5 is equal to 55. 55 minus 7 is equal to 48. 48 minus 9 is equal to 39. 39 minus 11 is equal to 28. 28 minus 13 is equal to 15. And 15 minus 15 is equal to 0. We have the series of 8. So it is 8 square. So the square root of 64 is 8. Find the square root of 89. 89 minus 1 is equal to 88. 88 minus 3 is equal to 85. 85 minus 5 is equal to 80. 80 minus 7 is equal to 73. 73 minus 9 is equal to 64. 64 minus 11 is equal to 53. 53 minus 13 is equal to 40. 40 minus 15 is equal to 25. 25 minus 17 is equal to 8. If something is remaining from the subtraction, so it is not the perfect square. Prime factorization. Here is a table showing the numbers in the prime factorization. Prime factorization. Here is a series of prime factorization sum of a value 256. So 256 is equal to 2 multiplied by 2, one group, 2 multiplied by 2, another group, 2 multiplied by 2, another one, and 2 multiplied by 2, which gives us the value 16. Property of a unit digit of square root. If a square number has 1 or 9 in the units place, then its square root ends with 1. If a square number has 2 or 8 in the units place, then its square root ends with 4. If a square number has 3 or 7 in the units place, then its square root ends with 9. If a square number has 4 or 6 in the units place, then its square root ends with 6. Square root of decimals. First example, square root of 23.04. Step 1. To find the square root of a decimal numbers, put a bar on the internal part. Place the bar on the decimal part. Observe as shown. Step 2. The leftmost bar 23 and 4 square less than 23 less than 5 square. Take this number as the divisor and get the remainder. Look at the figures properly. Step 3. The remainder is 7. Write the number under the next bar to the right of its remainder to get 704. Double the divisor and enter it with the blank on its right. Observe the figures as shown. Step 4. We know that 88 multiplied by 8 is equal to 704. Therefore, the new digit is 8. Divide and get the remainder. Observe the figures carefully. From all the division process, we get the answer as 4.8. Finding square by division method. We have the square root of 625. Step 1. To find the square of any number, put 2 bar on the internal part, as shown. Step 2. Find the largest number whose square is less than or equal to the number under the extreme left bar. Take this number as the divisor. Divide and get the remainder. Observe the figures carefully. Step 3. The remainder is 7. Write the number under the next bar to the right of this remainder to get 225. Double the divisor and enter it with the blank on its right. Observe the figure carefully. We know that 45 multiplied by 5 is equal to 225. Therefore, the new digit is 5. Divide and get the remainder. Observe the figures carefully. We get the answer 25. Estimating square root. In all such cases, we need to estimate the square root. We know that 11 square less than square root of 125 less than 12 square. So, 121 less than the square root 125 less than 144. So 121 is much closer to 125 than 144. Therefore, level is the estimating square root of 125. So this was all about our lesson square and square roots. Square roots are used throughout mathematics and have applications in many disciplines such as probability, statistics, physics, architecture, and engineering. Some uses of square roots in real life also include in finance. So studying about them is very important. Thank you, students.